So we are going to finish 3.2's lesson. So if you can remember, we did not finish the notes. We still have a few more down here to do. And then I'm going to have us do a few examples with whiteboards, and then we will do some problems on our practice pages. Now, what I need you to do is follow along with me in the video. Don't try to work on a practice page before finishing this video. The point, of the video is so that you have something to do while I'm gone. So please make sure that you're following along the whole time. What I would like you to have out is your notes. We still have these last two to finish, and then I would like you to get your whiteboard ready. So feel free to pause the video anytime if it feels like I'm going just a little too fast. Okay, now what we talked about yesterday was that we can take two linear equations and combine them. Step one was first to check to see if there's anything I can actually do in the parentheses. There's nothing I can combine in the parentheses because they're not like terms. Step number two was to look outside the parentheses and see if there was anything I could distribute. Now, we said technically there's a 1 here, which means if I distribute that 1 through, I would just get 3x plus 8, right? So we don't really have to do that. It'd feel kind of redundant and kind of silly. So instead, we just ignore the parentheses and just bring down all the terms, okay? Once we brought down the terms, then we could combine like terms. We had a couple examples yesterday. This one, there was something to distribute, so we distributed that through. And today, I want you to notice that these problems are just slightly different. Can you tell how they're different? Well, if you're noticing, what I would like you to see is that instead of a plus sign in the middle, we have a minus sign in the middle. This actually does change how we need to do this. And I'll explain what I'm talking about in one moment. Here's what we need to do. When you will go back up to this problem, remember how we said there was technically a 1 here? But if you distribute a 1, it doesn't make a difference. It's still just going to be the same thing that's in there, right? I want you to remember that because down here, now we kind of do need to think about that 1. Now, if there was a 1 outside this parenthesis, it wouldn't make a difference because 1 times 5x is still just 5x. 1 times 6 is still just 6. But now here's where things get interesting. If I put a 1 right here, I want you to notice that that's not a 1. That's a negative 1. And when you multiply things by -1, it changes every term's sign. For example, this is negative x, so it's going to turn this into a positive x because two negatives in multiplication make a positive. And this is positive 6. It's going to turn that positive 6 into negative 6 because in multiplication, one negative makes everything negative. So let's go ahead and distribute. Here's what I want you to write. Definitely put a 1 right there. Don't worry about this one so much. This one's really important, so put that 1 right there. Now I want you to show me the arrows that you are distributing. Go ahead and do that math. -1 times negative x is going to make positive x. -1 times 6 is going to make negative 6. Okay, so now we have officially distributed, and now this problem is looking more like what we're used to, like up here, right? Like that. Now we can just combine like terms. So I guess how this is different than what we were doing is just because that negative is now incredibly important, and so is that little invisible 1. That invisible 1 with a negative sign changes the game, okay? Let's go ahead and combine like terms real quick. I've got a 5x and an x. They're both positive, so let's just add them. That's 6x. I've got a 6 and a negative 6. Those are opposites, which means it just turns into 0, right? But now, if I say plus 0, that seems a little silly because anything plus 0, you're not adding anything to it, right? So my final answer is 6x. Things got kind of funky there. There we go, 6x, and then that is my final answer. Okay, So not so bad, right? That was just the new thing, is that negative makes a big difference. Let's go ahead and take a look at this next example. It's the next one in your notes. Okay, so step 1, is there anything to do in the parentheses? No. Step 2, check if there's anything to distribute. Now, obviously, like we said, there's like a ghosty one right here. Ooh, but he doesn't matter. He's not going to make a difference to these numbers, so I'm just going to rewrite them. This is now going to be 7y plus 5. But here's what my students make the mistake of every single year. They see that 2, and they're like, oh, let's distribute a 2 through here. But guys, that's not 2. That's negative 2. Negative 2 times 4y makes negative 8y. Negative 2 times negative 3 makes positive 6. Now we can combine like terms, like we're used to. 7y and negative 8y, signs are different, so we subtract. 8 minus 7 makes 1. Keep the y. Let's take the sign of the bigger number. The bigger number is 8, and it happens to be negative. Now let's do the 5 and the 6. They're both positive, so we're just going to add. 5 and 6 make 11. And it is positive 11. And since it's positive 11, that's how I know the plus sign goes in the middle. Okay, that looks pretty good. And honestly, if you put that as your answer, you'd be totally right. However, I want to make it look a little bit more, mature, like a mathematician. And mathematicians wouldn't necessarily write that 1 right there. So I'm going to rewrite it real quick. That's the same thing as negative y plus 11. Okay. Yeah, so 7th graders, that was the rest of the lesson. Please grab your whiteboard and your marker now. We're going to do some examples out of the book real quick. Don't worry, you guys will have plenty of time to do your homework. Please follow along with these examples on your whiteboard. I know sometimes I go a little bit fast when I record videos, so what I would like you to do is pause the video when I tell you to pause the video. And when I tell you to pause the video, I want that to be your chance to practice it on your whiteboard first, and then press play on the video so you can check to see how you did. I hope that makes sense. Okay, so over here in the book, in the exercises, these were all the plus ones, right? See, like we have a linear equation, but we're adding. And if you look, all of these are addition problems. We did a lot of that yesterday, okay? Today I want to focus on this page. This page has all of the subtraction problems. We're going to do these subtraction problems together. So, with your whiteboard, I want you to write this problem down. Negative 2g plus 7 minus g plus 11. Once you have it written down, I want you to try it on your own. Before you get started on trying it on your own, I want you to notice that we have a minus sign here, which means if we had a little 1 right here, that's going to make a big difference in what it distributes as if, right? It's going to turn everything in here negative. Go ahead and pause the video right now. Try this one on your own. When you get stumped or when you think you have the answer, press play and check your work. I notice that out here, it's just like there's a regular 1. So I'm not going to distribute anything. That's just going to be negative 2g plus 7. But like I said, technically there's a negative 1 out here. We're going to distribute that negative 1 through there. That's going to turn this into negative g and negative 11. Oh, hey, sidebar, by the way, do you guys agree that that's the same thing? Because it is. You can bring down that plus sign as long as you also include a minus for a negative sign, okay? Either way works. Okay, now that we've distributed that negative through, we can combine like terms. This is where I am also curious to see how you can do this on your own. So if you got this far, continue going, pause the video, see if you can do it on your own. If not, we're going to continue. We have negative 2g and negative g. Signs are the same, so we just add. That'd be negative 3g. Remember, we keep the sign they all had. Now I've got 7 and negative 11. Signs are different, so we subtract. 7, 8, 9, 10, 11. That makes 4. Who's the bigger number? 11. And 11 happens to be negative. Remember that negative sign that I just drew? He kind of acts as a minus sign for the expression as well. So you don't have to put a plus sign here, but if you did put a plus sign, you're not wrong. You're absolutely right, because my 4 is still negative, my 3g is still negative. Putting a plus sign here is not going to cause any issues. But this is your final answer. Negative 3g minus 4. And if you're like me, you don't really like how that minus 4 is off a little bit. It just looks like it's negative 3g and then a minus 4. I want to snuggle them up a little bit closer so that it looks more like an expression. Okay, hopefully you did okay on that one. Go ahead and erase your whiteboard. Let's try this one. Go ahead and pause the video right now. Write this on your whiteboard. Try it on your own. You can press play when you're ready, or if you got stuck and you want to see how to do it. But try to take the initiative to try it on your own first. There's no harm in trying. It's not like you're going to get, in trouble for having the wrong answer. Sometimes trying it on your own and learning from your mistakes is a better way to learn. I know technically there's a 1 out here, and I don't really have to distribute it because it's not going to make any difference. So if I rewrite this, it's just going to be 6d plus 5. But what we learned from this video is technically there's a 1 here, and that's not 1, that's negative 1. So when I distribute that through, it's going to change things. The 2 will now become a negative 2. The negative 3d is now going to become a positive 3d. My 8th graders do this all the time. And they always tell me that instead of actually thinking about the math, like 1 times 2, 1 times 3, they just tell themselves that everything in here is going to turn to its opposite sign. For example, this was a 2, so now it's going to be a negative 2. This is negative 3d, it's now going to be positive 3d. I think that's a great way of thinking about it, and it does save you some time. Hopefully you got this far after the distributing, and now we're going to add our like terms. We got 6d and 3d. Signs are the same, so we just add 6, 7, 8, 9. That makes 9. Whoops, that's not a 9. 9d. We don't have to worry about negative signs. So now let's go look at our next one. We got 5 minus 2. Now, guys, you don't always have to say signs are different, we subtract. When the big number comes first, it's just literally 5 minus 2, okay? That makes 3. And it's a positive 3. So I know how to put a plus sign. And there's your answer. I hope you guys did okay on that one. I hope you tried it on your own. Go ahead and erase your whiteboard. Okay, let's try this one. Go ahead and write it on your whiteboard. Pause the video if you need to, and try it on your own. Press play when you're ready to see what the answer is. I'm going to rewrite this as just 4 minus 5y, because there's nothing outside there to distribute, right? But now this one's kind of like the one that was in our notes. It's not a negative 1 that's getting distributed through here, it's a negative 2. So we need to actually multiply, okay? Negative 2 times 3.5. Well, I know 3.5 times 2 is 7. But don't forget, one negative turns everything negative. So this is now going to be negative 7y. Now I'm going to do negative 2 times negative 8. 2 negatives make a positive, and 8 and 8 is 16. All right, so far so good. Hopefully you guys are doing okay on this. Let's go ahead and combine my like terms. I have a positive 4 and a positive 16. Okay, we're just going to add them. That makes 20. I have a negative 5y and a negative 7y. Signs are the same, so we just add. 7 and 5 makes 12. keep the sign they all had, negative 12. Now remember that negative 12 is also acting as my operation of minus, so we can just leave it like that. However, if you put this, you are absolutely correct. So both of these are correct things, okay? You can know that by looking, is my 20 positive here? And is my 20 positive here? Okay, so far so good. Is my 12y negative here? And is my 12y negative here? Good, which means both of these expressions are the same thing. Okay, go ahead and erase your whiteboards. Okay, let's try number 22. Pause the video, try it on your own. Only press play when you're ready to see how to do it. Really, truly try to do this on your own. Okay. Well, I'm ready to start it. I see that I will not be distributing anything on that first linear equation, so I'm just going to rewrite it. It's 2n minus 9. Now this next one I am distributing, but I'm not distributing a 5. I'm distributing a negative 5. Okay. 2 negatives make a positive. Now 5 times 2.4. I call this doing bonus math. Bonus math is when you have to go do like other math to do the math you're trying to do. I'm going to go off to the side over here and do my bonus math so that it's not in the middle of all my work. 2.4 times 5. 1 decimal place. 12. So now I'll go back over to my real problem. This is now 12n. Don't forget the little n. Now I'm going to distribute negative 5 times 4. One negative makes everything negative. 5 times 4 is 20. All right. Hopefully you did okay so far. Let's go ahead and combine my like terms. 2n, 12n. Signs are the same, so we just add. Okay. Negative 9, negative 20. Signs are the same, so we just add and keep the sign they all had. This is now going to be negative 29. There's your answer. Okay, erase your whiteboard. Let's do one more. Here's our last one. Okay, actually, hold on. Oh gosh, I said that was my last one, but I definitely want to do 24 as well. How about instead of doing 23, can we just talk about it real quick? Quick little reminder. When there's a 1 in the numerator, I can take that divide by 8 and just distribute the divide by 8, okay? Let's remember that, because both of these would have been really easy to do their divide bys and get nice answers. However, here's what I'm thinking. While that's all great and all, we haven't done one, though, where there isn't a 1 in the numerator. So let's do this problem. I think this would be a great one to kind of see where we're at, okay? It's kind of a more challenging problem. Pause the video, write it down, and you can watch the video to see how we start this. There's going to be a lot of bonus math within the math to do this problem. So I'm going to zoom out a little bit to give myself a bit of a workspace over here. The first thing I need to do is take 3/4 times 3x. 3/4 times 3. I write my 3 as a fraction like this. And now you can just do top times top, bottom times bottom. That's going to make 9/4. Now, I know that's improper, but trust me, leave it as improper. It's okay. Now, that made 9/4 x. Okay, let's go do the next distributing property problem. It's right here, 3/4 times 6. 3/4 times 6 over 1. 6 times 3 is 18 over 4. Okay, we've got that first linear expression done. Let's go do the next one. Now, this one has a 1 in the numerator, which means I can use my trick of just take the divide by 4 to everything. However, how this one's different is because it's negative. So technically, take the negative divide by 4 to everything, like this. Okay, so 5x divided by negative 4, guys, just really look here for a second. Do you see that that's just 5 over -4 with an x hanging out? Leave it like that, okay? This is going to be negative, because remember, one negative makes everything negative, 5/4 x. And now look at this. It's just negative, negative. 2 negatives make a positive, so I'm going to put a plus sign right here. Leave it as 24/4. Now, oops, I was thinking in my head what it equals. I know 24 divided by 4. That makes 6, right? But leave it like this for a second, because look who you're going to be combining it with. And we already have common denominators, right? That's kind of nice. So leave it like that for 1 second, okay? Now let's go ahead and combine. I have 9/4 x, negative 5/4 x. Signs are different, so we subtract. 9 take away 5 is 4. And then leave it as a fourth. Bring your x. It's going to be positive because 9's bigger. Hey, guys, I know what 4/4 is. That's the same thing as 1 whole. 1 whole x, which is the same thing as just x. Okay, well, that's really easy. Let's go do the other set. 18/4 plus 24/4. 18 plus 24. 8, 9, 10, 11, 12. 42. Okay, so now we're going to have 42/4. 42/4. I know 40 times 10 makes 40. I know 40 times 11 makes 44. So is there anything in between that would make 42? I also know I could reduce this. I could take out a 2 and take out a 2. That would make 21 divided by 2. Now, if you look at this problem, you can very, very clearly see, can 21 get divided by 2 to get anything nice? Not really. I mean, it could be like a half, right? But let's go ahead and just leave it like this. I'm okay with this being improper for now. X plus 21/2. Could you also say that 21/2 is the same as, like, gosh, you could take out 10 of those 2's and have 1 left over? Sure, you could do that. That actually looks nicer. Don't get me wrong. Okay. Holy moly, we just did so much work together. Here's what I'd like you to do next. Back in your binder, turn the page. You have 3.2's practice page. Let's take a peek. At 3.2, we've got some addition problems. And then over here, we've got some subtraction problems. So be very, very aware of those negatives. One thing I want to remind you of on number 2 is there actually is a 1 right there, right? You have to be careful when distributing that -1 through. It's going to change the sign of everything in here, okay? All right, number 7 says, you earn this many points after completing this many levels in a video game. And then you lose, okay, lose, that's a really important word for now, this many points. Can you write an expression that represents the total number of points you have now? Basically, what it wants us to do is create something that looks like these problems, right? But the word lose is a good big clue that we're going to be using a subtraction sign in the middle. So I'll help you set this up, but then I want you to solve it on your own. It'll be 4x plus 12 minus 2x minus 5. Remember, you're going to have to distribute that little -1 through there, and then you may combine your like terms. Okay, good luck, you guys. I hope that this lesson made sense for you. And if you have any questions, try to remember them and ask me on Monday. All right, bye, guys.